The objectives for this video are to understand how variation in a dataset affects the standard deviation and to compare the standard deviations of two similar populations. This time series graph shows the number of home runs hit in both major leagues from the 1901 to 2013 seasons. If we were to describe what the graph tells us, we would probably note that there appears to be an upward trend in the data values, but something else that is worth noting is that there appears to be an increase in variation in the data values, particularly once you get past the 1960 season. So let's separate the data into two populations, the seasons from 1901 to 1959 and the seasons from 1960 to 2013. The two data sets appear very different in the number of home runs and the variation from season to season. Much has been made of this increase and its contributing factors. Improvements in equipment and technique are considered contributing factors. Also, an increase in understanding of the impact of nutrition and training on athletic performance. And then the admitted abuse of performance-enhancing drugs, especially in the 80s, 90s, and 2000s, are believed to be reasons why the number of home runs hit per season is so much greater now. In order to quantify the variation in a dataset, let's recall the process for finding the standard deviation that we learned in a previous video. Recall that the process for finding the standard deviation includes comparing each data value to the mean. Here, the mean of 1,088 for the dataset is plotted against the raw data values in the time series graph for the 1901 to 1959 seasons. The mean of 3,721 is higher for the 1960 to 2013 seasons, but notice also that the individual data values tend to stray farther from the mean. The calculation of the standard deviation requires that we first calculate the variance. Recall that in this process, the mean is subtracted from each data value and then squared. These values are then all added together. So the larger these differences between the mean and the individual data values, the larger the variance, and therefore the larger the standard deviation. So, due to the greater variation between each data value and the mean, we would expect the standard deviation for the 1960 to 2013 seasons to be greater than that for the 1901 to 1959 seasons. The standard deviation for the 1901 to 1959 seasons is 621.7. The standard deviation for the 1960 to 2013 seasons is 1,075. So if we did not have the graphs in front of us, but were instead provided with only the standard deviations for these two similar populations, we would gather from the standard deviations that there is more variation in the number of home runs in the 1960 to 2013 seasons than in the 1901 to 1959 seasons. In this video, we learned how variation in a dataset affects the standard deviation and compared the standard deviations of two similar populations.